How does the difference equation relate to IIR filters? Have you ever wondered how we can manipulate signals in the digital world? One key player in this process is the infinite impulse response filter, commonly known as the IIR filter. Today, we will discuss how the difference equation is at the heart of IIR filter design and its role in signal processing and control systems. The difference equation is a mathematical expression that describes how the output of an IIR filter is calculated. It shows the relationship between the current output sample and past output and input samples. The general form of this equation is quite straightforward. It can be written as y of n equals the sum of past output samples multiplied by specific coefficients plus the sum of current and past input samples multiplied by their own coefficients. In this equation, y of n represents the current output, while x of n represents the current input. The coefficients associated with past outputs are denoted as a sub k, and those associated with current and past inputs are denoted as b sub k. The negative sign in front of the sum of a sub k times y of n minus k indicates feedback, which is a defining feature of IIR filters. This feedback mechanism is what gives IIR filters their unique characteristics. The output does not depend solely on current and past inputs. It also relies on past outputs. This recursive nature results in an impulse response that can last indefinitely, which is why we call it infinite impulse response. To analyze the behavior of an IIR filter, we can use the Z-transform, which allows us to convert the difference equation into the Z-domain. This leads us to the transfer function, which is a powerful tool in understanding how the filter responds to different frequencies. The transfer function can be expressed as the ratio of the output Z-transform to the input Z-transform. By selecting the right coefficients, engineers can design IIR filters that meet specific frequency response requirements. This makes IIR filters incredibly useful in various applications, from audio processing to telecommunications. In summary, the difference equation serves as the foundation for IIR filter design. It provides a clear picture of how outputs are derived from inputs and past outputs. This understanding is essential for both theoretical analysis and practical implementation in digital signal processing systems. So, the next time you encounter an IIR filter, remember that the difference equation is the key that ties everything together.